friends, in this video I will explain the concept of slotted aloha for 6 marks. So pure aloha has vulnerability time of 2 into TF. This so be because there is no rule that define when the station can be sent. A station may send soon after another station has started or soon before another station it has been finished. So slotted aloha was invented to improve the efficiency of the pure aloha. So in this again with respect with the pure aloha will be having the drawbacks or the problems are present. To minimize or to overcome that one, it is going to introduce the concept of slotted aloha. So in slotted aloha we divide the time into slots of TFR and force the station to send only at the beginning of the time slot. So and then below figure shows what examples of frame collision in slotted aloha. So station 1 it has been sent, right, and then 1.1 and then frame 1.2, and then here the station 2 it is going to sending onto the frame 2.1 and then what frame 2.2, and then station 3 it is going to having 3.1 and then 3.2, and then station 4 it is going to sending onto the frame 4.1 and then frame 4.3. If you take this slot or slot 2 which will be having the collision, so and then slot 3 also which will be having the collision. Because a station is allowed to send only at the beginning of the synchronized time slot, if the station misses this moment, it must wait until the beginning of a next time slot. So this means the station which started at the beginning of this slot has already finished sending its frame. So there is a still possibility of collision if two stations try to send at the beginning of a same time slot. The vulnerable time is now reduced to 1/2 equal to the TFR. Figure shows that the vulnerable time is slotted aloha is 1/2 of the pure aloha. So by concluding this discussion, we can indicate that slotted aloha vulnerable time is equal to TFR. So next, throughput, it can be proved that average number of successful transmission for slotted aloha it is S is equal to G into e to the power of minus G. The maximum throughput will be the S max is equal to 0.368 when G is equal to 1. So next, another example, a slotted aloha network transmit 200 bits frame using a shared channel with the 200 kbps bandwidth. Find the throughput if the system produces 1000 frames per second, 500 frames per second, 250 frames per second. So we can refine this the 200 kbps into the 1 millisecond. So in this case, G is equal to 1, S is equal to G to the power of minus G, or S is equal to 0.368 or 36.8%. This means that 1000 into 0.0368, which is going to indicating 368 frames, it will be probably which will survive, and the remaining it has been discarded. So next, G is equal to 1 by 2. In this case, S is equal to G into e to the power of minus G, or maybe S is equal to 0.303, which means 30.3%. This means that throughput is the 500 into 0.030, that is 151 frame will survive. And then G is equal to 1 by 4. So in this case, we will be having a S is equal to 0.195 or maybe 19.5%. This means that 250 into 0.195, which is equal to 49. Only 49 frames out of 250 will probably survive. Thank you.